This lecture video will cover electrolytes. Please read the OER textbook chapter section 11.3. Substances that dissolve in water can be categorized into two groups depending on whether they can conduct electricity or not. Non-electrolytes are substances that cannot conduct electricity when dissolved in water. The reason for that is because they do not dissociate to yield ion. On the other hand, electrolytes are substances that can conduct electricity. The reason for that is because when they dissolve in water, they dissociate to yield ions. An electrolyte can be broken down into two groups. The first one is strong electrolytes. Strong electrolytes are substances that fully dissociate, which means that when they dissolve in water, they are going to dissociate to yield 100% of ions. And the weak electrolyte are the substances when they dissolve in water, they are only partially dissociated into ions. So that means it's going to yield less than 100% of ions. Here is the picture that is going to demonstrate the differences between strong electrolyte, weak electrolyte, and non-electrolyte. Now let's take a look at first picture. First picture represents an aqueous solution of non-electrolyte. The molecule of non-electrolytes do not dissociate or break into ions. As you see in this picture here, their atoms still stay intact. Okay, so they still stay the same. They did not break into ions. Okay, and in this beaker, you see that it contains two electrodes, a negative electrode and a positive electrode. These two electrodes is connected to power supply and also the light bulb. Okay, and because the non-electrolyte did not provide any ions, therefore in this scenario here, there is no charge carrier that is going to complete the circuits between the negative and positive electrodes. Therefore, in this case, the light bulb will not turn on. So we can conclude that the non-electrolyte are not able to conduct electricity because of that, right? Because it doesn't contain the charge carrier. Okay. The second picture is going to represent an aqueous solution of strong electrolyte. Strong electrolyte are the molecules that can dissociate in water completely, which means it's going to yield 100% ions. Okay, so that means in this case, you will see that those molecules are no longer stay as molecule. They are going to dissociate into cation and anion that floating in the solution. Okay, so that means in this case, these ions are going to behave as charge carrier that is going to, for example, the negative charge is going to flow toward the positive electrode, right? And the positive ion is going to flow toward the negative electrode. These charge carriers are going to allow for the circuit to be complete. Therefore, in this case, the light bulb can be turned, and you will observe that the light will turn on very brightly. And as you see, the strong electrolyte will be able to conduct electricity. So now let's take a look at third picture. Third picture is the aqueous solution of weak electrolyte. The definition of weak electrolyte are the compound that can dissociate only partially. And as you see, some of the compounds stay as the molecule. Some partial molecule will dissociate into ions. And this small amount of ions will be able to carry the charge between the two electrodes to complete the circuits. Therefore, in this case, the light also will be able to turn on as well, but it's going to be turned on dimly. Okay, so it's not going to be very bright because it doesn't have a lot of ions to carry the charge. The next thing we are going to take a look at is we are going to take a look at the lecture demonstration of conductivity.
Hi everyone, in this lecture video, we are going to take a look at conductivity of several substances. Okay, so what I have here is I have light bulb that connected to two electrodes. Okay, so these two electrodes are separated and they are connected to, I'm going to connect these to power supply. Okay, so if I connect these to power supply, nothing is going to happen because the two electrode is not touching. So therefore, it's not going to complete the circuit. So therefore, the light bulb will not be able to turn on. Okay, so what I'm going to do is I'm going to unplug this and I'm going to connect these two electrodes to just make sure that our light bulb is actually work. Okay, so I'm going to connect this with the copper wire. And you are going to see that the electron would flow from one electrode to another through this copper wire. Okay, so I'm going to connect this to power supply. Okay, so that's how you are going to see, right? So as you see, copper can conduct electricity, so therefore it's going to allow for the current to flow from one electrode to another and causing the light bulb to be able to turn on. Okay, so that is going to be what we are going to observe today. Okay, so if the substance can conduct electricity, it's going to turn on the light bulb as you see here. Okay, let me turn it off. All right, so what we are going to see is that I'm going to start with the first one. We're going to start with the DI water. Here is the deionized water, which ions has been removed. So it's just pure water. So I would like you to make prediction real quick before I start here. So what would you think if I submerge these two electrodes into water? Would you think it's going to be able to turn on the light bulb? Yes or no, right? So let's make that prediction. All right, let's test your prediction together. So I'm going to plug this into power supply. Okay, so now let's submerge this into water. So as you see, right, pure water do not conduct electricity at all, right? So there is nothing happen, right? Okay, so the next one I'm going to look at is tap water. Okay, so tap water is water that contain other ions as well. For example, like fluoride, chloride, right? So those ions that is, those are the one that present in tap water. So let's make a quick prediction here. What would you expect to happen with the light bulb? Okay, so let's test this together. Okay, so if you look at this closely, you will see that the filament is actually illuminate a little bit, not much. Okay, so let me actually turn the light off so that way you see it clearer. So here's tap water. Okay, so I'm going to submerge electrode to this. Yep, you start to see that it's actually glowing, right? So that means in this case, tap water do contain some small amount of ions that allow for the ion to flow from one electrode to another, right? So it's able to turn on the light bulb, but it's not much, right? So compared to like the one with the copper wire that we see earlier. So that means it's, in this case, does conduct electricity, but not much. Okay, so the second one that we are going to take a look at is, so let me unplug this and then wipe this electrode real quick. Okay. The second one we're going to take a look at is going to be solid sugar. Okay, so we have solid sugar here. Okay, again, do make some quick prediction before we test this out. Okay, so I have solid sugar. Okay, so I'm going to turn it on and going to dip this in. Okay, so you will see that solid sugar cannot conduct electricity at all, right? So there's nothing glowing. Okay, so in this case, you will see that the solid sugar is going to be in the crystal form, right? So that means there is no, it's indicated there is no ions or anything that allow for the charge carrier, right? So that means in this case, the circuits will not complete between the two electrodes. Okay. All right, what about if I add pure water or DI water into sugar? What do you think would that happen? So next one, what I have is sugar solution. Okay, so I dissolve sugar in DI water. Okay, so let's make some prediction real quick. Okay, so this one is sugar. All right, it's still not turn on the light bulb. Okay, so that means in this case, sugar solution is non-electrolyte. Okay, so it cannot conduct electricity. Okay, now let's take a look at the next one. The next one is vinegar solution. Okay, so vinegar contains acetic acid. Okay, so which is molecular compound similar to sugar, right? So sugar also molecular compound as well is contain only non-metal. So this one also is contain only non-metal. So this vinegar solution, what do you think? Whether it's going to turn on the light bulb or not? Okay, so let's make that prediction real quick. Okay, so I plug this into power supply already. Okay, so let's take a look at next. Oh, this one is actually do conduct electricity, right? So it's actually causing the filament to glow, right? So in this case, it does turn on the light bulb. So that means we can conclude that vinegar is actually also electrolyte in this case. All right, so let me rinse it first. Okay, so let me rinse this. Next, we are going to take a look at solid ionic compound, and I'm going to use sodium chloride. Okay, so sodium chloride is salt, right? So I'm going to plug this in. Okay, so let's take a look at whether sodium chloride can conduct electricity or not. Okay, so I submerge this electrode in. So you will see that nothing happened, right? So the light bulb did not turn on. So that means we can conclude that solid ionic compound cannot conduct electricity. Okay, so the reason for that is because in the crystallized structure, right? So ionic compound, the ion, the cation and anion are fixed together in a rigid structure. So there is no movement of ions. It doesn't allow for the movement of ions. So in this case, those ions cannot behave as charge carrier. Therefore, you will see that it will not be able to complete the circuit, right? Because there is no flow of electron between the two electrodes, right? So therefore, the light bulb will not be able to turn on. Okay, so that means in this case, we see that if you have solid ionic compound, it will not conduct electricity. Okay, so what about if I dissolve this with water to make an aqueous solution? What would be the case? Okay, so let's take a look at this. Okay, so this is what I have. I have a solution of sodium chloride. Okay, so I just add salt and water, pure water together. Okay, so I'm going to plug in the power supply here. Okay, so what do you think? Whoa, it's turned on light bulb very brightly, right? So if you compare this with vinegar earlier, this one is even brighter than the vinegar one, right? So that means in this case, this one can conduct electricity very, very well, right? So that means salt solution can conduct electricity very well. So salt solution would be electrolyte, right? So this is what we refer as strong electrolyte, okay? All right, so the next one we are going to take a look at is going to be hydrochloric acid. But before we do that, let me actually rinse this real quick. Hydrochloric acid is a molecular compound. It's a molecular compound that is acid. Okay, so it's similar to acetic acid earlier. Okay, so I would like you to predict this result as well. Okay, so we have hydrochloric acid here. Okay, so let's take a look at this. Whoa, it's the same result as sodium chloride. So that means in this case, we can conclude that hydrochloric acid is also strong electrolyte, right? Because it's conduct electricity very, very well, right? So, all right. Okay, so let me unplug this and then rinse this. Okay, next one, we are going to take a look at another ionic compound, which is what we call sodium hydroxide. Okay, so it's an aqueous solution of sodium hydroxide. So this solution is made from solid sodium hydroxide dissolved in water. Okay, so let's take a look at this. Yep, it's the same result as sodium chloride, right? Because this is the aqueous solution of the ionic compound, right? So it's the same result as sodium chloride. All right, let's rinse this. Next one, I'm going to have another ionic compound. It's called copper sulfate. Okay, so in this case, this one is not on the list, but I just want to show it. Okay, so this one is solid copper sulfate. Okay, before I dissolve it in water, so it's solid. Okay, so I'm going to do the same thing. What do you think would happen if I stick the two electrodes in here? Well, as we expect, right? So nothing happens. So similar to when we have solid salt, sodium chloride, right? This copper sulfate is ionic compound and is not going to be able to conduct electricity in the solid state because all their ions are fixed in rigid structure. There's no movement of ions. Okay, so it's similar to what we see in sodium chloride scenario. Okay. All right, what happens if I dissolve this copper sulfate in water? Okay, so if I dissolve this copper sulfate in water, you are going to get the copper sulfate solution. So the color is very beautiful blue here. Okay, so what would happen then? Okay, so one solid ionic compound dissolved in water. Okay, so it's become an aqueous and it's going to be able to conduct electricity. So as we expect, okay, so similar to the sodium chloride scenario. All right, last one, I'm going to test out Gatorade, right? So we know that every time when you work out and, people would be like, oh, you need electrolyte, right? You need to drink electrolyte or whatever. So Gatorade would be like one of the choice, right? So let's take a look at this, right? So I have just, I just poured this from the bottle. So it's turned out to be the same color as copper sulfate, but let's take a look at this. So what do you think? Yep, it's the same thing, right? So we'll be able to turn the light bulb as well, right? So as you see, so that means what we are going to do next is we are going to take a look at different ingredients in Gatorade and figure out which one exactly that are electrolytes. Okay, so we're gonna take a look at that. All right, that's it for this lecture demo. Thank you for watching.
All right, here's a summary of the lecture demo. Okay, so we see that pure water cannot conduct electricity at all, right? Because it cannot turn on light bulb. Whereas if you're looking at tap water can turn light bulb on, but very dimly, right? So for solid sugar, it's going to be no light, right? So a sugar solution, when you add pure water into sugar to make sugar solution, still no light. Okay, so for vinegar, it's going to be able to produce light, right? So solid table salt, no light. When you add pure water into salt, sodium chloride, okay, so this one is going to produce very bright light, right? In comparison to the vinegar. Okay, so vinegar is dimmer. Okay, so and the next one is hydrochloric acid. So this one is going to also produce bright light as well. And sodium hydroxide solution also going to produce bright light. And copper 2 sulfate also going to produce bright light. Okay, so the last one is granate, also going to produce bright light as well. Okay, so what does this data tell us? Okay, so that's what we're gonna take a look at next. Okay, so according to that, right, so what we can classify is that we can classify that the deionization water or pure water, right, solid sugar, aqueous solution of sugar, and solid salt, right, solid sodium chloride, these are not going to be able to conduct electricity. Okay, so these are non-electrolytes. Okay, so those tap water and vinegar that be able to turn the light on dimly, so we are going to be able to classify them as weak electrolytes, and the rest would be classified as strong electrolyte, right? So if you looking at this list, you will see an aqueous solution of ionic compound, right? So those are going to be strong electrolyte. Okay, so that will be some of the acid that can be classified as strong electrolyte as well. We're gonna take a look at later. Now let's take a look at the ingredient of Gatorade. Okay, so which one of these, right, that are electrolytes that allow for the conduct electricity, right? So let's take a look at this. Okay, so we have water. We know water is not going to be electrolyte, right? According to what we see, not sugar for sure. Dextrose is also another sugar, so that's not going to be it. Citric acid. Okay, so if you go back to this observation that we make it before, we have vinegar, which is acetic acid, right? And we have hydrochloric acid. Both acid are electrolyte. Whether they are strong electrolyte or weak electrolyte, you are going to learn how to classify that in Chem 123. So for now, just know that whenever that you see acid, know that they are going to be electrolyte. So in this case, citric acid, right, so an acid is going to be classified as electrolyte along with salt and other ionic compound as well. So now we're going to take a look at what conclusions can we draw from the observation. Okay, so from our observation, we can conclude that the substances in solid state are non-electrolyte. Okay, so even though you have salt, but if it's not dissolved in water, if it's still in solid state, it's not going to be able to conduct electricity. So that is going to be non-electrolyte. When you have solution of molecular compound, okay, so molecular compound mean when you have non-metal and non-metal, those are going to be non-electrolyte. Okay, so this is except an acid. Okay, so for example, we see it before, right? Hydrochloric acid and acetic acid. Next one, when you see acid, okay, so acid is going to be electrolyte. Whether it is going to be strong electrolyte or weak electrolyte, you are going to learn about that in Chem 123. And then the last one, solution of soluble ionic compound, they are going to be strong electrolyte. Okay, so again, whenever that you see ionic compound that are soluble, they are going to be strong electrolyte. Ionic compound is going to be when you see metal plus non-metal. And it's also going to include the ionic compound that contain ammonium ion as well, such as ammonium hydroxide or ammonium chloride. The next thing we are going to take a look at is we are going to learn how to represent the difference between strong electrolyte, weak electrolyte, and non-electrolyte in terms of chemical equations. Okay, so in terms of what is going on exactly in molecular level. Okay, so let's take a look at, again, the definition of each of these first. So strong electrolyte can dissociate completely. Okay, weak electrolyte can dissociate only partially. Okay, the last one is non-electrolyte do not dissociate at all. If you got this definition down, you should be able to associate this definition into the chemical equation. Okay, so let's take a look at example of strong electrolyte, which is sodium chloride. Okay, so we know that sodium chloride in aqueous, right, is going to dissociate. So that means in this case, when you are dissociate them, you are going to break them apart into cation and anion. So in this case, you're going to end up with sodium cation and chloride anion. And as you see, the phase would be still in aqueous. Okay, so again, the reason why sodium chloride can conduct electricity because in solution, this molecule is no longer exist because it's going to completely dissociate into sodium ion and chloride ion. And these ions are going to behave as charge carriers. Okay, so that's why they are able to conduct electricity. The next one is weak electrolyte. Okay, so weak electrolyte, an example of this would be acetic acid. So this molecule here is going to only partially dissociate, which means that the arrow that we are going to use is going to be different from the first scenario. Whenever that something completely dissociate, you are going to use only one head arrow. But if it's only partially dissociated, it means that it's kind of want to go this way and it's also want to come back this way as well, right? Because it's not fully break apart. Some of them still stay as the molecule. So that's why you are going to use the equilibrium arrow. Okay, so this is what we refer as equilibrium arrow. Okay, so it's gonna go into two directions. Do not use this arrow. This arrow here doesn't represent an equilibrium arrow. Okay, so don't use that. Okay, so you have to do one half arrow on top and the other half on the bottom, go backward. So this arrow is going to represent that the molecule is going to partially dissociate. And how it's going to partially dissociate is going to partially dissociate into cation, which is an acid, right? And then plus anion acetate. Okay, so that means in this case, if you start with 100% of this, you are going to have less than 100% of each of these ions. That's what it tells you. Okay, so that means in this case, we have less of the charge carrier in comparison to the strong electrolyte case. All right, last one, non-electrolyte. Okay, so for example, in this case, we have sugar. Okay, so sucrose. So sucrose, when it's dissolved in water, is not going to dissociate at all. Therefore, it's just going to stay as it is, right? So that means in this case, it just stay as it is. It stay as a whole molecule because it's not going to dissociate. Next, we are going to take a look at molecular view of dissolving process. Okay, so we see this in the previous lecture video before. Okay, so pretty much you are going to have the polar molecule that has partial negative charge and partial positive charge, right? So this polar molecule here is going to interact with ionic compound. In this case would be, I'm going to choose sodium chloride. Okay, so sodium chloride is going to be present in a crystallized structure, which means their electrostatic force between sodium ion and chloride ion is going to attract each other and it's going to form this crystallized structure. And as you see in the previous video, you will see that as the sodium chloride is submerged into water, the water molecule will start to solvate, right, or surround the ions of the sodium chloride. Okay, so between those cation and anion, and pull those ions out one by one until there is no longer crystallized structure of sodium chloride, and that process is called solvation process, and you are going to be able to see that sodium chloride eventually dissolve in water. And the interaction between water molecule and ion, this is what we refer as ion dipole. Ion dipole is the strongest type of IMF. It is an electrostatic attraction between ions and polar molecule. Next, we are going to take a look at molecular view of dissolving process for the non-electrolyte. Okay, so a molecule that I'm going to use as an example would be methanol molecule. Okay, so methanol molecule is going to be polar molecule. Therefore, in this case, methanol would be able to dissolve in water, okay, because polar can dissolve in polar molecules. Right, so in this case, if you're looking at molecular view, you will see that when methanol dissolves in water, methanol molecule will not dissociate. Okay, so it stays as a whole molecule. Okay, so it did not break apart. Therefore, in this case, the interaction between water and methanol will not be ion dipole because methanol doesn't create ions, right? So in this case, the interaction between water molecule and methanol would be hydrogen bonding instead. Okay, so this hydrogen atom in methanol right here is going to behave as hydrogen bonding donor. Okay, and this oxygen here is going to behave as hydrogen bonding acceptor, and that is going to be the interaction between the two. Okay, so same as for this one too, right? So it's going to be this interaction right here. Now let's summarize what happened for the dissolving process of ionic compound. Okay, so what happened is cation going to get surrounded by oxygen of water because oxygen going to have the partial negative charge, right? So this is partial negative. It's going to interact with the cation. Okay, so be able to pull it apart from the compound. And for the anion, okay, so the anion is negative charge. It's going to get surrounded by hydrogen of water because hydrogen is going to have partial positive charge. So these two are going to interact, right? So eventually it's going to be able to pull apart from the compound. Next, how does the dissolving process for a molecular compound differ from an ionic compound? Okay, so ionic compound, as we see, right, is going to get separated, right? So the ions will get separated by water molecule. But for molecular compound, the molecules are still going to stay intact. Okay, so, but it's going to surrounded by water still, but it's not going to dissociate. All right, so here's a summary of what we learned in this video. Okay, so you learn the difference between non-electrolyte, weak electrolyte, strong electrolyte, and you also learn about dissolving process. and also ion dipole interaction as well. Please start working on homework 11.3 as soon as you can.